I have the chance of closing with this talk about scaling Swagger-based web API and with Google Cloud Endpoints. So I'm Guillaume Laforge. I'm a developer advocate for Google Cloud Platform. I've put the slides up there if you want to look at them later on, and let's go. So, three aspects in this, even just in the title. So what does Swagger bring to the table? Why am I going to speak about Swagger? That's going to be my introduction. Then scaling. What do I mean by scaling? Well, basically having lots of people hammering your API and Cloud Endpoints, because that's the solution I'm going to use in this presentation. So first of all, okay, I used Swagger in the title. I should say Open API Specs, but still, people still, know Swagger a bit more, and we still have to do some evangelization around the Open API Spec term. And this is Dan Shirley, is my colleague at Google. There was a challenge to make an Open API Spec logo with pancakes. And that's my colleague who actually won, because the others were not all that great, I would say. And there's a theme there, because I'll come back to pancakes later on in the demo. Okay, so for me, the benefits of API specs are that, so contracts first is trendy, but the benefits that having an API definition language are that the contract is the source of truth. So everybody agrees that, okay, this is the contract, this is how the API should be working, whether you're the one implementing, creating the contract, or implementing the API, or using, if you're an end user, or testers, or whoever, there's a central source of truth. So this is useful. It's especially useful for facilitating communication and collaboration, because sometimes, and I've seen that for a customer, where the company who was working on the API was actually just designing the contract and was outsourcing the implementation of the API. So if you want to be sure that the company doing the work is implementing the API correctly, it's good to have a contract to prove, hey, no, there's a problem with the API, it's not this endpoint, it's not the right method or something. So it's great for improving the communication and collaboration between teams. And it's great for tooling as well. So one of the things that an API definition language allows is generating stuff, like server skeleton for implementing, or for having at least a basic skeleton for an API, and then you have to fill in the gaps. Creating client SDKs, automatic client SDKs rather than hand-rolled ones in different languages. So if you use something like the Swagger Code Gen, you can generate skeletons for your Open API Spec-powered API pretty easily. But also for testing. So if you want to create test stubs or even mocks, especially when you have several APIs talking to each other, interacting together, or if a team is working on an API that you depend upon, and then they haven't implemented the API yet, you may be using a mock out of the spec of this third-party API. Static documentation, you can create documentation. You can also create or host in an API portal with key provisioning and things like that, or use something like the Swagger UI or more advanced playgrounds to be able to play with the actual API. So this is coming kind of not for free, but at least is enabled by the fact of using something like Open API. That said, regarding the code generation aspects, etc. Let's be cautious with code generation in the sense that usually it overwrites whichever customization you might have made. So you might have to be careful with that in the process. So the second aspect of this talk is about scaling. So scaling, let's say with a Google style or at Google scale, if you host an API on the Google Cloud Platform, there are different compute options. So there's Google App Engine, 2 flavors, Flex and Standard. It's basically just a pass or even a serverless, although it's not decoupled into small functions. It's still an application, but you can cut it into modules as well. And you don't have to operate it. So you throw your application at it, and then it's taking care of scaling for you. No DevOps kind of stuff, no administration. It's going to scale out of the box just for you. The other option is Container Engine, which is using Kubernetes and containers. This is the one I'm going to use in the demo at the end. So it's based on containers. So it's easy to define different containers interacting together, and it's somewhat perhaps easier for testing interactions between containers. And then Compute Engine, where you've got full control. You can even customize the VM images, install stuff on the VMs, etc. But then the scaling might not be transparent or automatic. You might have to configure things around. And for the demo, I'm going to use the Container Engine. Right, so now Cloud Endpoints. So Cloud Endpoints, there was already a Google Cloud Endpoints v1, let's say, which was solely for Google App Engine, Java and Python. So you couldn't use your own framework, your own language, etc. So it was somewhat limited, I would say. And this new version of Cloud Endpoints that was released a couple months ago, so it's still pretty recent, is much more open and based also on Open API. So Cloud Endpoints, that's Google's solution for API management on the Google Cloud Platform. So what is API management? That's the process of publishing, documenting, overseeing APIs in a secure and scalable environment. That's the first definition that comes up when you Google search that. And interestingly, if you run an API on Google Cloud Endpoints, you're using the very same architecture and infrastructure as all the APIs used by Google. So let's say, I don't know, the AdWords API, Translate API, whatever. It's all based on the same infrastructure. And I assume that it scales, obviously. And what's interesting with Cloud Endpoints is that all the configuration, like how are you going to monitor this method, this endpoint, etc., it's all done through Open API Spec. So whether you're doing REST or JSON style or HTTP kind of APIs, but it also works with GRPC. So I'll speak about that quickly at the end as well. 3 key aspects in API management, whatever use case you're onto, public, private, mobile apps, etc. So you want to secure your API, control access, authenticate users, etc. You want to monitor, log the calls, look at your key metrics, and you also want to scale. So not just scalability, horizontal scalability with many parallel and concurrent users you may have, but also latency. Latency is also important. And sometimes API management solutions with a central kind of proxy that does the API management and logging and intercepting calls, relaying the calls to the actual API code that you have, sometimes adds some big level of latency, but this is not the case with Cloud Endpoints. So this is more or less what it looks like. So you have clients calling into what we call the ESP, the Extensible Service Proxy. It's actually just a container that you can also use and reuse, which is the proxy in front of your app, your API. And what's interesting is that it's co-located with your API code, right? So it's not, and as your API and the app scales, Google Cloud Platform might spin up many more apps, many more containers, etc., or instances on on Compute Engine. But then there's always one proxy along your API. So the proxy is always as close as possible to the API application. And then the proxy calls into the service management layer and control APIs of the Google infrastructure, and then you can use the console to look at the logs, etc. And I'm going to show you that during the demo. So what's nice with the ESP, the Extensible Service Proxy, is that there's almost zero latency, less than 1 millisecond, because the proxy is associated very closely to your API. So it's pretty thin, no network hop, because you don't have to call the proxy, which would be located elsewhere, etc. And it's based actually on Nginx, this proxy, and it will actually be open sourced. And you are actually able already to use the container, so it's possible to do that already, even if you're not using Google Cloud Platform per se for the deployment of your app. But you'll be able to have a look at the sources, help us improve it, etc. So now onto my little pancake demo. Okay, so I've built a small demo. Where shall I start? Okay, here. So I've got a little application, or perhaps I could, let's go with the curl directly. So it's just a list of pancakes, and a pancake has got an ID and a title. So let's say I'm going to call that API with curl. Actually, I'm going to use, I don't know if you know about this little tool, JQ. It's really awesome, because it's going to do syntax highlighting for JSON, which is pretty cool. It's more beautiful to read. Oh, but look, there's a little problem there because I didn't provide an API key. Where is my ID, by the way? Because I could show you. Yeah, it's there. I'm going to increase the font size. Whoops. Up. Yeah, so no, that's. I wanted to start with the Swagger, the Open API Spec, sorry. It still says Swagger, so I'm allowed to say Swagger, right? So yeah, there's or I'm going to start with the model. So there's an ID, property, a title, and then I'm using an API key security for all my my path, my methods. So there are 3. So there's /pancakes with a get, so that you retrieve all the pancakes. There's a post to post a new pancake recipe, and then there's pancake/ID if you want to retrieve one particular pancake. Okay, so that's the structure. So here, okay, I didn't provide an API key, so I must have it somewhere. Yeah, so this is it. I'm going to call it, and then, okay, I've got already a few pancakes available. I can, I don't see my cursor. I'm going to put that up. And I'm going to copy and paste the this key there. Up. And I'm going to put the pancakes ID there. And okay, I'm going to retrieve one pancake. Then I must have a post somewhere ready. Up. Where is it? Somewhere. Yeah, there. Okay. And I don't know if there are some special pancakes here, like Swedish pancake, perhaps? Swedish pancake. Does it exist? So, okay, there's a new Swedish pancake, and if I do up with the key up there, so this, yeah, the Swedish pancake is right, at the bottom there. It's a very quick demo. So I'm not really showing that it scales, but if you would try it would scale. So I actually created the specification for that API. And so this is a small Ratpack application. I don't know if you know this framework. It's a nice framework. Here I'm using the Groovy programming language to make things concise. And you can see, so here I have my Docker file because I'm using Container Engine. So I'm saying, okay, it's based on Java 8. This is like my entry point, which is the startup script for my demo. And then I expose the port, which is going to be the port where the application listens. And then I'm actually using Kubernetes there to say, okay, so this is the service that I'm exposing. And I've got two containers, the my app container and the extensible service proxy, which is there, which delegates to my API. So this is more or less how it works. And then there's a command with gcloud deploy, etc., to deploy that directly onto onto the Google Cloud. And now let me show you this part. Let's increase a little bit. Yeah. So once you've deployed an API, actually the API can also be consumed by others from the API platform within the Google Cloud. So you can also, just like you would use in Google Cloud Platform project, let's say the Translate API, your APIs can also become available to the API catalog provided by Cloud Platform. So here I created this Pancakes API, and I'm able to see, it's going to show up. Yeah, so here are the requests that I made. Were there some errors, the latency, and the various methods, latency, etc. And then you can also view the associated logs, which is part of the logging view inside the Google Cloud Platform. Yeah. So that's basically it for the demo. Back to the slides, which are there. Okay. So what else? I also mentioned that Cloud Endpoints supports GRPC. So if you want to do GRPC-style APIs and not just REST or RESTful APIs. But both, I mean, you can use Open API specifications to actually work with both JSON-style APIs and gRPC. And actually, this is what we're doing inside Google as well, as we are able to serve both gRPC and REST JSON surfaces with the same contracts. Right, and as far as I know, at least that's what the product manager told me, there's no other solution providing gRPC-based APIs management. So I trust him, I didn't do the study. Right, so summary. So key points, managing APIs. So you want to secure your APIs. So I showed the usage of API keys, but you can use also JSON Web Tokens, Auth0, Firebase, API keys, or also your custom mechanism. There's a dashboard to view your API metrics, creating alerts, reviewing the logs. You can also scale on Google Cloud Platform with App Engine, Container Engine, and Compute Engine. You actually have the choice in terms of protocol, whether it's JSON, HTTP APIs, or gRPC. You can use any language or framework, as long as it runs like in a container or elsewhere. You can use whichever you want, which was a limitation with the first version of Cloud Endpoints before. And although I'm speaking about Google Cloud Platform, it doesn't just run on Google Cloud Platform. If you use the service proxy, you can put that in your own on-prem infrastructure or in a third-party cloud. So whether it's Azure or AWS, etc., it's also possible to benefit from these features, even if you don't run inside the Google Cloud. And it's pretty much open. We're trying to base the product on standards like Open API specifications. We're also interested in the open source story because gRPC is actually an RPC mechanism which is open source, but the service proxy, the ESP, is also based on Nginx, and we will also open source it. All right, current state, Cloud Endpoints is in beta, but only in alpha for gRPC. And that's about it. Thanks a lot for your attention. So you can have a look at the slides there. Don't hesitate to ping me on Twitter. I actually have a plane to coach at 7:25, so I'm not going to stay here very long, I'm sorry. So some pointers, the slides, Nordic endpoints on Bitly, endpoints on the Google Cloud. There's also a presentation by a colleague of mine on managing gRPC-based APIs. And then if you're interested in looking more into the scaling options, the compute options from Google Cloud Platform, that's the link there. Thanks again for your attention.
All right. Great talk from Guillaume. Don't want him to miss his plane, but I do want to give the audience a chance for one question if there is one. Don't make me turn to mine.
One.
I just wanted to ask you your views on other ways of describing interactions with an API. For example, GraphQL. Do you see this as a competition or as something that you can use to cooperate with Open API?
It might be complementary. So I guess I'm not sure you can, that would be a good question to ask to the GraphQL experts, but I'm not sure you can really model a GraphQL API with Open API specifications. But what I'm thinking is that somehow, at least that's probably how I would address that in the sense that I could use this mechanism to still provide a proper REST API for most of the consumers of my APIs, but provide the facility of adding also a GraphQL front end in order for some particular customers and consumers to actually customize the way they want the payloads, etc. But that would be interesting to see how we can model or not GraphQL with Open API specs. And if that's the case, perhaps we can, yeah, I don't know, something to explore. Great question.
All right. Very good. Guillaume, thanks again.
Thanks a lot.